All right, guys, welcome back. Today, wanted to go over different kinds of data structures in coding, and thought I'd cover the hash map. We won't necessarily cover all the topics of a hash map, but I'm going to try to introduce, um, what a hash map looks like. Um, we're going to be using the constructor method for this, or classes are basically constructors. I'm just going to use a constructor, and it's going to tell me that I can make it into a class. Doesn't really matter. Well, it might matter for reasons that I don't know. So what we're going to do is we're going to say function hash table, and kind of like um, with your classes, you're going to have everything as this dot whatever. Okay. So what have we done here? We have created a new object, um, new function, which has a table. A function is actually an object, so same thing. Um, Objects, sets, maps, which are just special kinds of objects in JavaScript, um, all basically are hash tables under the hood. I think more or less. Objects are arrays under the hood, and there's something going on with the indexing. What a hash table does is, whereas an array you have the index 0, 1, 0, yada yada yada. There's 0, 1, 2, 3, etc., etc. Um, what a hash table is doing is, um, whereas the key for um, the array is the index uh, sequential. Um, for a hash table, the um, key value is also a number, but it's determined by um, the content of the property, or content of the value. So, um, my name Chris, it's going to have a specific numerical value attached to it. Someone named Brian is going to have a numerical value. Hopefully, they're different. We're going to get into issues with that as well along the way. Um, so um, we'll get into figuring out how we're going to do that. For now, we've created a table, and I think if we table. It is an array with 117 empty items. It's one of the only ways you can get an array of that, or array with empty items, is to create it this way. We can't do it this way because we need empty slots to be able to push things into, because they're not going to go in sequentially. Where they're going to go in this table, or this array, is going to it's not going to be just putting things in slot 1, putting things in slot 2, etc. Um, so we need to have a way to set the prop. That's going to take in a key and a value, and that is going to Okay. And then we need to have a way of getting the prop key. Same to do. And then we return this table. So okay. Now normally I would want to get access to this prop A. We need to set the index to a numerical value because this is an array and all the index values are numbers, right? These keys aren't numbers. So maybe we just, if we want to do something like set this to 5 and 5, well, one of them is going to work. But as you can see, we are very quickly going to run into issues because I can no longer get, it's just returning wide because prop A, B, and prop and C aren't doing anything. We're just going to index 5 each time. So we need to have a way to take that property, this key value, and turn it into a number. It doesn't need to be in our function. It can be outside of it because it won't be accessed as a this dot. It's going to be accessed as part of it's going to be accessed by the methods, the functions that are attached to the class or the constructor. So this is what's called a hash function. You may have seen it. You probably have seen it mentioned elsewhere. You've got a hash, which is usually a prime number, or at very least a semi-prime number. Probably going to be a bit higher than this. I think they need to be higher to prevent or reduce the likelihood of collisions. And then for I equal 0 less than s dot length I plus. There are other ways of running a hash. I think this is a pretty straightforward way of doing it. Taking some sort of value attached to the individual characters of the string. If you're not dealing with strings, you're going to have to do something else. If I were putting in numbers, this wouldn't work. If I were putting in objects, this wouldn't work. There would have to be a different way to do it for those, obviously. Now, unfortunately, as we're looping through this, we're going to get fractional numbers. As you may be aware, arrays don't actually have indexes for fractional numbers. The other thing that's going to, oh, no, we're not dividing, sorry. It's going to get very large. So we need a way to keep this within the bounds of the size of our table, which is 117, another prime number. So what if we pass in the length and we get the remainder after it's divided by the length? So that, yeah, return hash. Our key and this table length. Now, when we run this, we get blue, which is prop A. If we were to make this 3 and just console log hash, we might have collisions. Let's see. Yeah, we do. We run into problems. These are just overwriting each other. And then if I table, maybe if I make it slightly bigger, we won't have collisions anymore. We don't. So it just so happens that there's a likelihood of these producing the same hash number. That's why you typically want to deal in very large numbers for your array, which is why I originally had it at 117. And we can see blue for some reason ends up at the first. So prop A, the hash value is 1 for that. And then tall and then wide. And they're kind of evenly spaced out, which doesn't necessarily happen. But these these keys are all relatively similar, with just one character difference between them of, one value. So maybe that has something to do with it. But as I pointed out, right, we're going to run into collisions. There's a few different things that you can do with this. The first, and you can do this in a multitude of ways, is to say, okay, instead of setting it to the value, each of these values within this array are actually arrays themselves, and each time you're setting something, you're actually just pushing it to that little array within the array. That's one option. And then when you go to get it, everything gets stored as a key value there instead of just the value. When you get it, you check to see if the key matches the key that you've passed in, and if it doesn't, you go to the next item in the array, and so on and so forth. You're still ending up basically having to do the same sort of search methodology for a normal array, which is not, that's O of n time. But your n in this case is actually much smaller because you're not dealing with the full array. You're dealing with, 1 over 117 in this instance, the size of the array. That's much smaller, and that's much better, right? So when you're dealing with large data sets, still something like that is to be preferred over just a giant unorganized array. You can also do it as a singly linked list where you set the first value to the head node with a key and a value. You check to see if the key matches, and if it doesn't, you go to the next node in the linked list. That it's still going to be roughly the same in terms of search time. It's going to be a little bit better on setting over time for large data sets, because you won't have to reorganize your memory. The way linked list works is preferable to arrays in memory. So that is an option where you have So you have your giant array, and then our, in, index is equal to list node with key value. Actually, what it would look like is that's what that would look like. So you could do something like that. That's very and then the other option is to just have it say value or val. Right. Those are very similar in terms of the way you're organizing it. It gets different. It gets implemented differently in memory, but at least structurally, it looks very similar. There's another option where if you run into a collision problem, you just call a function that resets the size of the array and pushes everything from that old table into the new table at the new indexes. That can be kind of difficult to do. So you've still got to store the keys in there as well. Right now, we're not storing the keys in there. So the ability for us to resize this is fairly limited. We would have to do it as the linked list or the or no, we would have to get the keys in to do the linked list or the array of arrays. We couldn't do any resizing right now. We could you can see now we've got the arrays are storing differently. So if I wanted to hash dot get prop a, it's going to return correctly now if I don't include this. It's going to return an array. So yeah, I think next time I'll cover resizing, but I think that's kind of enough for now, just to sort of introduce what hash tables are. Sets and stuff like that are operating very similarly under the hood to this. So you don't necessarily use them a lot, but I think it's important to understand, especially when trying to implement your own sort of structured data, the different ways that you can do it. And if you understand how it works under the hood, you can see what methods might be preferred to others. So yeah, I hope you enjoyed the video. As always, drop a like, hit the subscribe button. Let me know if you guys want to see other stuff. For now, I think I'm going to continue focusing on different kind of data structures. So until next time.